Hello, I'm Yasai for Psych 12 and today we'll actually be going over week 5's lectures. This week we went over simple experiments in statistical validity, and this video will summarize how researchers can set up experiments and how to test for statistical validity. We'll start by talking about how to group participants, which is an important step in every experiment. Participants can be grouped through an independent groups design or within groups design. An independent groups design is a design in which various groups of participants are put in varying levels of conditions in terms of the independent variable, which will also later on be referred to as IV. It is also known as a between subjects or between groups design. In the world of independent designs, there are two designs that one must know. There's a post-test only design in which, after being randomly assigned IV conditions, participants receive the manipulation according to their IV level and then are tested. And then a pre-test post-test design, which is similar to the post-test design, but instead of participants just being tested after the manipulation, they are given a pre-manipulation test too. There are some advantages and disadvantages to both the post-test design and the pre-test post-test design. A post-test only design is only good for situations where a pre-test cannot be utilized. A pre-test post-test design can help to see the effectiveness of random assignment, and it can help out eliminate any problems with the dependent variable, also known as DV. But it is susceptible to being contaminated as a result of multiple steps. On the other hand, we have routine group designs, which one group of participants is given all levels / conditions of the independent variable. It is also known as Witten subject design. In the world of the Witten's group design, there are two designs one must know. There is the repeated measures design, in which participants are exposed to an order of independent variables, with the dependent variables being measured, and the concurrent measures design, which is a design in which the participants get all the different levels conditions of independent variables all at once. An advantage of within groups design for internal validity is that since participants are in the same conditions for all independent levels being measured, there is no chance for selection effects. Another advantage for within groups design in terms of statistical validity is that it eliminates extraneous differences that traditionally occur between participants in distinctive groups. Within group designs have a few disadvantages. This include order effects, which is when being exposed to a condition affects a participant's reaction to the next condition. Practice fatigue effects, which is when participants can either get better or worse in terms of their response through the length of multiple trials. And lastly, demand characteristics, which is when participants might change the way they behave if they guess what the goal of the research is. Now you might be wondering, how do you conclude that an experiment is statistically valid? To conclude that an experiment is statistically valid, one must do certain things that will be later explained in the next few slides. Firstly, one must be able to measure effect size and statistical significance and understand null effects. Effect size begets the question of how strong is the difference between conditions. I have also attached a picture of the effect size formula, which was what first popped up. It is important to know what the effect size formula is for the class. As you can see, it's M group 1 minus M group 2 divided by SD, both groups. SD stands for standard deviation. And the rest you probably know from a lecture in class. To understand effect size, one must understand cont Z and what it represents. Cont Z is a standard effect size that takes into account the mean and standard deviation. When D is 0, there is no effect. When D is 0.2, there is a small effect. When D is 0.8, there is a large effect. Statistical significance is the likeliness of a result to be due to random chance. It is important to note that the larger the effect size, the less likely for chance to have a strong effect. Meaning larger samples are less likely to be biased by outliers. In terms of statistical significance testing hypothesis, one must know the difference between a null hypothesis and alternative hypothesis. Null hypothesis alludes to no difference existing between conditions. Alternative hypothesis alludes to a difference existing between conditions. P-values are utilized in statistical significance testing to decide how likely it is to get the result if the null hypothesis was found true. If the p-value is less than 0.05, it is considered significant, which means that collected data is unlikely if null hypothesis is true, and you can reject null hypothesis. If the p-value is greater than 0.5, then it is non-significant or not significant. When the term null effect is utilized, it means that what was tested is actually not statistically significant. There are 4 possibilities to explain this. Firstly could be that the difference between the two groups is actually not large enough to conclude anything. There's too much variation within the groups to find the effect. The sample size is too small. And lastly, there's just no effect. That's where we'll end it for this week. Thank you.